In this recording, we are going to discuss a second example of how to solve a system of linear equations, two linear equations with using matrices. So step one, you form a matrix equation. All right, that's the first step. The coefficients of the variables, these are A and C, will be used to form a 2 by 2 matrix. So as you can see, the format 5 and -3 will make a first row, and 2 and 3 will make a second row. Now, with the variables from the order left to right and up towards downwards, make a column matrix with the variables. So as you can see, the coefficients multiply into the variables technically, as can be seen in the equations. And this will be equal to another column matrix with the constants. Okay, as you can see in the equations, these are equal to the constants. So that's step one. You form a matrix equation. A 2 by 2 with the coefficients, a 2 by 1 with the constants multiplying by the 2 by 2, and is equal to the column matrix with the constants. No, with the variable, the coefficients multiplying to the variables. Please take note. Okay, and then equal to a column matrix with the constants. Okay. So pause the video and take note of that. Step number 2 is to find the inverse of the 2 by 2. Now, the inverse of a 2 by 2 matrix is basically the adjoint divided by the determinant. Simple as that. So you find the adjoint by swapping the elements of the leading coefficient, or you exchange positions of the leading coefficient. Okay, so 3 will take the position of 5 and 5 will take the position of 3. And the remaining entries in the non-leading diagonal, that's 3 and negative 3 and 2, their signs will change. Their position will remain, but their signs will change. So -3 becomes a +3, and the +2 becomes a -2. And the determinant in the denominator, you multiply the elements of the leading diagonal, that's 5 times 3, subtract the product of the elements of the non-leading. So that's 2 times -3, which you get -6. So that's 15 minus a -6. That's 15 plus 6 will give us 21. So here we have the inverse matrix. Okay. The inverse of the 2 by 2. Again, you pause the video and you write this down. Take note of this. Always view a math video with pen and paper. Step number 3, you multiply the inverse to the column matrix of the constants. Okay, take note, since the inverse, which is the first, has 2 rows, and the product will also have 2 rows. Okay, so your answer will also have 2 rows. And the column matrix has 1 column, so the product will also have 1 column. Hence, we are going to get a 2 by 1 matrix after this multiplication. We are going to get a column matrix after this multiplication. All right, so we are going to multiply the inverse, here it is, multiply to the column matrix of the constants. And as you can see, we have to divide by 21. That's the determinant right here, under here. So the way you multiply matrices, you multiply the rows times the columns. So the 3 times -10 plus the 3 times 17. Okay, I repeat, when you are multiplying matrices, the elements of the rows of the first multiply to the elements of the columns of the second correspondingly. First, second, and they are joined by a plus. Okay, so the products are connected with a plus, always a plus. So 3 times -10 plus 3 times 17, and that will give us 21, a first entry of the product. And to get the second entry is we go to the second row and we're going to apply it to the same column. So -2 times the same -10 plus 5 times the same 17. And that will give us 105. And finally, we divide by 21. you divide each element in the product by 21. That's how you divide a matrix by a scalar quantity. Okay, you divide each entry by that very same number. So 21 divided by 21 is 1, and 105 divided by 21 is 5. So here we have the product of the inverse multiplied to the column matrix of the constants. And the final step, which is step number 4, you equate the column matrix with the letters, the variables, yes, okay, to the final product. Okay, so equate the column matrix with the letters or variables to the final product. So the column matrix of AC is equal to the column matrix of the final product. So therefore, A must be equal to 1 and C must be equal to 5. So basically, that's how you solve a pair of linear simultaneous equations using matrices with two variables. And to grasp this, you can look at the video again and you can involve yourself by writing, practicing as you are going through the video, and then try an example of your own.